Welcome back to Geometry, Chapter 12, Section 3 in this book. Today we're talking about the surface area of pyramids and cones. So a cone is like an ice cream cone, pyramid is like what they have in Egypt. They can have a square base or they can have a triangle base. So let's talk about pyramids. The base, is what it's sitting on. This would be considered a lateral edge because it's going up, where these are the base edges, the ones that touch the ground. The pointy part is the vertex. All the pointy parts are vertices. Okay, if you are Indiana Jones at the Temple of Doom and you are rappelling down into the pyramid, not Temple of Doom, whatever the first one was, and you're rappelling down into the snakes, that's the height. But if you are on the outside of the pyramid sitting on it and you slide down, that's the slant height. And they are not equal. The slant height is more. It's longer to slide down than to rappel down. That makes sense, right? So this one is a square base. It's got 5 sides, the bottom, and then 1, 2, 3, 4 on top. If you look at this side, that lateral side, and if we pulled it off, we could stick it right here and look at it, and it's a pyramid where the height of this pyramid, it is a triangle, and the height of this triangle is the slant height. So if we take that triangle off and stick it right there, we could figure out the area of this triangle when we're figuring out the surface area. But the height here is the slant height. The height going down into the pyramid is Indiana Jones rappelling down into the snakes. Okay? So this one, it has a triangle base, and it's got 4 sides, the bottom and the 3 lateral sides. It's regular if it's a regular polygon base, meaning all the sides are the same, and the height is in the center. It's not like skewed over some way, like someone pushed it. Okay, so that's our basic thing. Oh, and a cone is like an ice cream cone. It's smooth all the way around with a circular base. All right, so here's some math. We're going to do it. We're going to say this is our pyramid. Now, what you should do is make sure you read the examples in the book and follow along, because I'm going to be doing them. But look at them, stop the video and make sure that you understand them too. All right, so this is the first example, and this time our height right here is 321, and our side right here is 300, and it is this square pyramid that we're looking at. So first of all, what they want is the area of this little triangle. They want that, but before we can get it, we have to get the slant height. So what they want is the area of this pyramid, of this triangle, but before we get it, we need the slant height. So how we're going to get, so they call slant height L. I wrote SH for slant height. It's also C here. Now let me show you where this came from. If we, on this pyramid, we went out from the center part to the edge and then went back up along the slant height, you're looking straight on this. So it's like there is a triangle that goes, like if you could look at the pyramid from the side, there's a triangle that goes from where Indiana Jones goes down over to here and back up, and it's this triangle. So the whole thing around is 350. So from halfway where Indiana Jones went down to the edge is half of 300, which is 150. And the height that he rappelled down was 321, and we want the slant height. So that would be, this is the inside of the pyramid, that's the outside. The slant height is on the outside, the height, and going out to the edge, the base That's all inside the pyramid, if you can imagine this. And this is what gives some people problems with this, is trying to imagine where this is from. So hopefully you can imagine it. Okay, so how we're going to get the slant height is a squared plus b squared is c squared. It's the hypotenuse, it's the c squared. So a squared is 321, b squared is 150. Then take the square root of both sides, and the slant height, which is also, they do it as L, is 354.32. Now we want the area of, oops, wrong color, I wanted to do it in red. We want the area of one of these side triangles, so we'll say it's this one. And because it's regular, all of them are the same, but we'll say that one. So we take this triangle, and it's right here. The base of it's 300. The height is the slant height. It's this. We peeled it up, we got a triangle, and that's the slant height. So it's a half times 300 times 354.32. And that's the answer, 53,148. And they base this on a real pyramid that's in Memphis, Tennessee. I didn't realize how much Tennessee was into Egyptian and Greek stuff until we went to Nashville, and they have a Parthenon there, and it's got Athena in it with a little Nike. I didn't know they were all into that, but they're big into ancient Greek and Roman stuff in Tennessee. All right, and there's a really good place you can get a hot dog called I Dream of Weenie, and it's in an old 70s VW bus. Anyway, so this is the formula for the surface area of a regular pyramid. So this time we didn't get the surface area of the whole thing. We just got it of one of these sides. But there's a formula. It's the area of the base, which that makes sense. The area of the base is going to be one side, plus 1/2 times the perimeter times the slant height. So it's a half times you go all the way around the perimeter times the slant height. And that will give you the area of a regular pyramid. It's really the same formula for a cone. Remember, for a cone, the base is a circle. What's the area of a circle? Pi r squared, cornbread r round, right? And 1/2, that's the same. And the perimeter, the formula for perimeter of a circle, that circumference, is pi times the radius. So those are the same, and then slant height is the same. So really it's the same formula. It's just that if it's a cone, it's a circle, so it's pi r squared, and its circumference, which is pi radius. Okay, so now here is another one of these. We want the surface area of the whole thing. And it's a pyramid. Its base has got 6 sides. The slant height is 8, and the radius kind of thing from the center of the hexagon to the side is 3 times the square root of 3. And if you remember, it's not really a radius. It's a radius if it goes to the vertex, but if it goes to the flat part, it's a apothem. That weird word, apothem. And that's what this is. It's an apothem. So now the area of these shapes like this is equal to 1/2 apothem times perimeter. So 1/2, 3 times the square root of 3 times the perimeter. Each side is 6, and we have 6 of them, 6 times 6. Put it all in your calculator. It's 54 times the square root of 3. You'll probably get a decimal number here. It doesn't matter, it'll still work. Okay, so this is the area of the base plus 1/2 times the perimeter. We already said the perimeter is 6 times 6 because there's 6 sides and there's 6 each, times the slant height, and they gave us the slant height as 8. Put it all in your calculator. Whoop, there it is. More fun with sound effects. Same thing with a cone. The slant height is 6. The radius is 4. This one is a radius because it's a circle. So the surface area of this cone is pi r squared, so pi radius squared, pi 4 squared, plus 1/2 pi times the radius times the slant height. Put it all in your calculator. It's 40 pi, which is approximately 125.7. So I think these are really pretty easy because you're using stuff you already mostly know, and these two formulas are so much alike. All right, come back. We're getting close to the end. Math is great.